We learned about the phase changes that occur between the liquid and gas phases. Those are vaporization, which can also be referred to as boiling or evaporation, depending on the context, and condensation. Then we learned about the phase changes that occur between the solid and liquid phases. Those are melting and freezing. But did you know that substances can go directly between the solid and gas phases? These are a little more removed from the everyday phase changes we see all the time, but they do happen. These phase changes are called sublimation and deposition. What sort of substances would undergo these transformations? A common example of sublimation involves carbon dioxide. If we take carbon dioxide gas and pressurize it so much that a solid forms, that's dry ice. But at standard temperature and pressure, solid carbon dioxide will sublimate. That is, it will tend to go back to the gas phase. So carbon dioxide molecules are constantly leaving these bricks of dry ice and going into the atmosphere. That's why you see this spooky mist that's perfect for Halloween parties. Sublimation, just like melting or vaporizing, is endothermic. It requires energy to overcome the interactions in the solid phase and liberate the particles into the gas phase. This energy is called the enthalpy of sublimation, and it will be specific to a particular substance depending on the interactions that are made in the solid phase. A common example of deposition involves water. On a cold winter's day, if it's a bit humid, meaning there is a lot of water vapor in the air, these water molecules can deposit on a surface, like a window, to form frost. The crystalline pattern we see is different than regular ice because the water molecules never existed in the liquid phase first. They went directly from the gas phase to the solid phase. As this is the opposite of sublimation, deposition will always be exothermic because as the interactions form between the particles in the solid phase, they will reach a lower energy, and so that energy is released. The energy of deposition is the same as the energy of sublimation, just opposite in sign, so we can say that the energy of sublimation is released during deposition. And now we know about all of the phase changes.